Honors Chemistry, this is lesson 26. It's a one lesson for the 1 unit of nuclear reactions. And you need to watch the instruction video to understand how to do this lesson, so please do that first. And then go ahead and you can do this lesson. So the instructions are, for this first set of problems, is to write a formula for the nuclear reaction for each of the following. So you're going to need a periodic table to do that. Okay, so we're going to begin with uranium-238. So the first thing we'll do is we'll write that as it's uranium, and the periodic table tells us that uranium has an atomic number of 92, meaning it has 92 protons, and the 238 is the mass number, which is the total number of protons plus neutrons added together. So if you take the difference between these two numbers, that'll be how many neutrons that it has. Alright, so the first thing we're going to do is we're going to do an alpha particle. And again, you need to watch the instruction video to know what's going on here. Alright, so alpha particle is 2 protons and 2 neutrons. So what that means is that this is going to decay. It's going to give off an alpha particle, 2 protons and 2 neutrons. So whatever's going to be left after this is going to be 2 protons short. So it's going to have 2 fewer protons than that. So that's going to be 90. And the mass number is the total number of protons and neutrons, and it's going to lose a total of 4 protons and neutrons together. So 2 protons, 2 neutrons, that's a total of 4. So this number is going to decrease by 4. So that's going to be 234. Okay, so the identity of the element is determined by the number of protons. That's the atomic number. This bottom number, that's 90. So we come over here, and we see that number 90 on the periodic table is thorium. So that means when it lost that alpha particle, it became a thorium atom. And then what you add to that is the alpha particle. So what is an alpha particle? It has 2 protons and 2 neutrons, which means there's going to be a total of 4 protons plus neutrons together. And what has 2 protons? That would be helium, atomic number 2. So it's basically giving off a helium nucleus, even though this did not come from a helium atom, it came from the uranium atom over here. Okay, and that's the final answer. So that's how you would write a balanced nuclear reaction for an alpha particle decay of uranium. Again, what has to this number, the number on the left, to balance the equation, or for the equation to be balanced, this number 238 has to equal 234 plus 4, whatever's on the right, and it does. This number 92 has to equal the numbers on the right, and that's 90 plus 2 is 92, so it does. So that is a balanced nuclear reaction. That's how you write a balanced nuclear reaction. Okay, a beta particle. So a beta particle, we're going to start with the same thing that we did above, 238 and 92. Okay, so a beta particle is an electron. We can write this up here just for reference. So this is 2 protons and 2 neutrons. That's for an alpha particle. Beta particle is 1 electron. Okay, and a gamma ray is just pure energy. It has no mass, it has no charge. Right, so beta is basically losing an electron. So what does that mean? Let's come over here and draw what is on the instructional video again. A neutron, which is neutral as you know, can be thought of as being a proton, a positive charge, attached to an electron, a negative charge. Okay, so very loosely, that's what a neutron is. This is a neutron. And what a beta particle is when this little electron flies off into space. It just takes off. So when that happens, after that happens, the electron will be out here in space somewhere, and all you'll have left is a proton in the nucleus of the uranium. So what that means is, the bottom line is this: you turned a neutron into a proton. By losing this electron, this neutron turned into a proton. Okay, so if we come over here, when beta decay happens, when this electron flies out and you turn a neutron into a proton, remember this is the number of protons. And you just gained a proton. You turned a neutron into a proton. So that means the element over here is going to have 93 protons. It's going to have an atomic number of 93. Now, remember that 238 is the total number of neutrons plus protons. And what we just said is we lost a neutron, but we gained a proton. So this number is not going to change. Minus 1 neutron plus 1 proton, you still have 238 neutrons plus protons. So the mass number is going to stay the same. So now we have to come to the periodic table and see what element number 93 is. And it's Neptunium number 93, Np. So what we've created is that new element. And what we gave away, what went away, is an electron which has no mass. We have always said that electrons have no mass, but it has a negative charge, a 1 minus charge. And that's what flew off into space. So again, we can check to see if we're balanced. 238 on the left side of the arrow equals the right side is 238 plus 0, that's 238, so they balance. Over here, 92 on the left side, 93 minus 1 is 92. So the right and left side balance there. So that's the nuclear, that's the equation for the nuclear reaction. Okay, finally the gamma ray. That's pure energy, so it's not giving up anything with mass or charge. So we'll just write gamma. Okay, and that's going to be uranium-238. 92 is going to produce uranium-238 92 plus, this thing means gamma ray. This funny little symbol there. It's the Greek letter gamma. Okay, so it's given off a gamma ray. It hasn't lost any protons, electrons, anything else. It hasn't lost any charge, so it's essentially the same. Okay? All right. Okay, let's go on now. Let's go to thorium-232. So we're going to start with alpha. It has 232 protons plus neutrons. And when we come over here, we looked up this one before. Thorium is a number 90. Its atomic number is 90. So we're going to write that here. And so this is alpha decay. So that means it's going to lose two neutrons and 2 protons, an alpha particle, 2 and 2. So the 2 protons here, it's going to decrease by 2. That becomes 88. That's the number of protons decreases by 2. This is the number of protons and neutrons together, the mass number, and it's going to lose 4 of those. 2 protons, 2 neutrons. So that's 4 is going to be, this is going to be reduced by 4. So that's going to become 228. So now we have to see what element number 88 is. And we come over here and we see that it's radium right there, radium. Plus the same thing we had up here. The equivalent of a helium nucleus. 2 protons, 2 neutrons. That's the alpha particle. Alright, beta. Start with the same thing. Okay, so again, what beta is going to do is it's going to turn a neutron into a proton and throw off an electron. So that means we're going to gain a proton. And the number of the mass number, let me draw a line between these two. So crowded there. The mass number is going to stay the same. You lost a neutron, that reduces this number by 1, but you gained a proton, so it increases it by 1, so it stays the same. So that's going to be 232. And for element number 91, we have to come to the periodic table. And that's going to be protactinium. Okay, so that's Pa. That's all you have to call it. Just call it Pa. So it's Pa plus the electron. So again, it's an E. It has no mass, so the mass number is 0, and it has a charge of -1. That's an electron, has a -1 charge. All right, and then gamma. Again, no mass, no charge. So that means both the mass number and the atomic number are going to stay the same, as is the element, plus the gamma ray. By the way, when you write the gamma ray, you can do it the way I did it above, or if you want to put numbers on it, since it doesn't have any mass or any charge, you can put a 0 there and a 0 there. You can do it that way, or you can just leave it like that. Either way, it doesn't matter. All right, I'm going to do one more, and this is what I did for the class on period 1. So I think doing the rest is not that hard. I think you guys can all figure this one out, right? So alpha, again, watch the video. Watch the instruction video first. Okay, so this is radium 226. So we have to come to the periodic table to see what the atomic number is for radium. We used it before. It's 88 right there. Okay. And it's going to throw off 2 protons and 2 neutrons, so that's going to reduce the number of protons, the atomic number, by 2, becomes 86. And it reduces this by 4, the 2 protons and 2 neutrons, that's 4. Total, the mass is reduced by, so that's going to be 222. Come to the periodic table and find out what element number 86 is, and it's radon. Whoops, right there, radon. Okay. A noble gas. Okay. Rn. Plus the equivalent of the helium nucleus. Okay. Again, everything has to add up here. This side has to equal this side, and this side has to equal this side when you add the numbers up. Okay. Beta. Okay. So again, we're turning a neutron into a proton, so the 226 stays the same. But we increase the atomic number of protons by 1. So we have to go find out what element number 89 is. It's right here. It's actinium, right there. AC. Plus the electron. Okay, finally the gamma. And nothing changes, it just lets off a little electromagnetic wave of energy, plus the gamma ray, that right there. Okay, that's how you do these. Little repetitive. I gave you 3 more to do, so do those on your own. Those are the ones I'll check. If you don't understand it, come to tutoring. Okay, let's see what else is on this assignment. Okay, so we talked about, and this is going to be a question on your district final, is how much each of these 3 particles, alpha, beta, and gamma rays, what they can penetrate. So what I want you to do is write down any of these particles that'll penetrate in each of these substances. So air, for example, all of them can fly through air. So that's going to be all 3. And this is on the instruction video. So all 3 of them can penetrate. What about paper? Well, we said that alpha particles can be blocked by paper. They don't go through paper. So, but beta particles and gamma rays do. So you're writing down which ones do go through these things. So this would be beta and gamma. Okay, so it's very clear. The rest of these are very clear. Watch the instructional video and it will make it clear what the answers to the others are. Okay, but you need to know that for the district final. Okay, all right. Finally, I want you to describe nuclear fission. It's described in the second to last slide, and nuclear fusion is described in the last slide. Just 2 or 3 sentences. And what do fission and fusion have in common? Well, I'll tell you one thing they have in common. They both produce energy. Okay, see if there's anything else they have in common. But go ahead and describe them in about 3 sentences or so for each of these. Okay, and that's the whole assignment, all right? It's straightforward. right off the instruction video. Okay, so go ahead and do that, and we will see you in class.